Good evening, everyone, and welcome to the Amateur Radio Technician class, session number 6. During our previous session, we had our usual curriculum progress review. We took a look at the practice exam links. We had Q&A. We also discussed Zello. We demonstrated the difference between the terms electrical and electronic. We also went into some components such as resistors, capacitors, inductors, batteries. We dealt with what are semiconductors, and then we went into diodes, LEDs, transistors, FETs, and then we had our question pool review. We also had announcement on emergency communications, and we also discussed an upcoming webinar. So this is our agenda for this evening. And yes, good evening, Adish. Good evening, Camille. And good evening, Norman. Great to have you. So the agenda for this evening, we will do we did our curriculum progress as we would normally do. We will look at that. Then again, we'll put up the links to the practice exams. We will also just look at the course material that everyone should have had. Then we get into discussion of some of the technical topics such as water schematics. Then some more components again. We go look at switches, transformers. We then discuss the concept of rectification. Also, we'll have a look at tuned circuits, and then some more components such as the single pole double throw switch. We look at relays, meters, integrated circuits. We'll discuss what's a voltage regulator. Then we'll also talk about fuses, shielded wires, followed by our usual question pool review. And then we will talk about the date for our next session. So when we look at our curriculum, which is the list of top-level topics that we have on your screen, we will see that we have progressed pretty well, and we are on the second topic. And all things being equal, we expect to finish topic number 2 this evening. So by next week, we should be moving on to topic number 3. So this is just to give us an idea where we are in respect of the entire course and how our progress is going. Again, we always remind all students to consider taking practice exams. It's never too early to take practice exams. And I take the opportunity to congratulate all the students who would have taken exams recently, whether it's the technician, general, and in some cases, extra class. Well done indeed. Congratulations to all students. Right, so just a reminder of the course material. We are using the No Nonsense Technician Class License Study Guide by Dan Romanchik, call sign KB6NU or Kilo Bravo 6 November uniform. All students would have also received some other supplemental information, but this book in blue is the one that we're using, and you should have your PDF copy. Again, any student without it, please send us an email or WhatsApp, and we will ensure that you get your copy. Okay, a reminder that we have been using an analogy when we are discussing electrical principles, electrical circuits, or electronic circuits. We have been using the water analogy. So when we have a component that is electronic or electrical in nature, many times we will use an analogy that is similar to water circuit component that matches the electrical circuit or electric circuit or electronic circuit version. And hopefully that will help us, that analogy will help us to understand. So we put this up here again just to remind ourselves that we're using or will be using some analogies to describe some of the components. Okay, so let's get on with some of the technical material for this evening. So we want to discuss the concept of a schematic. So we have been discussing circuits, and on your screen on the right hand side here, what you're seeing is called a schematic. It is a circuit, but the term that we're being introduced to describe what's on your screen is a schematic. And we have a definition that you need to learn for the exam. And we say that the name of an electrical wiring diagram that uses standard component symbols is a schematic. So let's break that down a little bit. You said it's the name of an electrical wiring diagram. So we know this is a wiring diagram. And it uses standard component symbols. So we have been introducing all participants to some symbols associated with the components that we have been discussing. And this evening we get into more components and we'll see what those symbols are. So when we combine those symbols in a wiring diagram like this, it is called a schematic. Exam question. Another way to say it, and also another exam question, is that the component connection. So these are components. So if you recall, what is this? If you say it's a resistor, you'll be quite correct. What about this symbol here? If you were to say that looks like a transistor, you would be quite correct. And so on. We have learned about several of these symbols. And they're saying that component connections are accurately represented in electrical schematics. So that's just a statement, but it's also a question in your exam. So we give you some extra information in terms of what a schematic is. So it's a visual representation. So this is what it looks like on the right-hand side. Or a diagram, which is also what it is, using symbols. And so we have the symbols for resistor, symbol for battery, symbol for a lamp. Lines, so you will see lines connecting the components. So you have a resistor that's connected to a transistor. So we have lines and they connect the components. We also may have some labels. So we'll either have a name or maybe we'll have some other label to indicate what the item is. So we could have a number or we could have a name of it. And it also shows how the components are connected or related to each other. And it does not depict what the physical appearance is. It does. Notice that during the course, we are showing you the symbol and we are actually showing you also what the component looks like. But in a schematic, you don't actually see what the component looks like. It uses the symbols. So this is what a schematic is. Right. So let's now talk about a schematic that has components, same diagram that we looked at before, and these are all exam questions on your left-hand side. So we need to know that each of these components has a name. It's called something. We would have learned pretty much most of them on the schematic already. So component 1, how do you know what component 1 is? Well, it's labeled by the digit 1. So you have this component here. This should be familiar to us. We just talked about it, but there's a 1 next to it. So this is component 1. And they will ask you, what is component 1 in figure T1? So figure T1 is this schematic. So we have labeled our schematic as figure T1. So in the exam, when they ask you about figure T1, there's going to be this diagram here. This is what they're referring to, the schematic. And they will ask you about component 1. So you just need to look where the 1 is, and this is component 1. What is it? Well, you would be quite correct if you were to say that this is in fact a resistor. So component 1 in figure 1 is a resistor. And there'll be a few questions like that. They will ask you, what is component 2? What is component 3? And so on, right? So component 2, what is component 2? So we have a 2 here. So this component here is a transistor. So component 2 in figure T1, again, figure T1, that's the entire schematic, is a transistor. We recognize the transistor, what it looks like, the symbol for a transistor. We have just added some labels here onto the schematic. This will not be in your exam. You will not see these, what's in blue here. We have just put it in for, as we are learning, for further clarification, to emphasize. Hopefully it will help us. But you will not see these labels inside of the exam. They will ask you, what is component 1? What is component 2? So we also need to learn a bit more than just what the component is. We need to know the function of what component 2 is. We talked about transistors the last time. We said that it could be used as a switch, it could be used as an amplifier. So those are some of the things we said about transistors. But in this case here, they're asking us, what's the function of this component? This component 2, it's a transistor. And we need to know for the exam that it is controlling the flow of current, meaning we are switching in this case, right? Switching on or off. So it's controlling the flow of current, because remember, in an electronic circuit or an electrical circuit, it's electrons that flow. And when the electrons flow, it's called a current. So that's what they mean by the component in figure T1, component 2, which is a transistor. What it does, it controls the flow of current in the circuit. You have the battery here, and once this transistor fires or it's on, it will control the flow in the circuit, and this lamp will light. So we need to know this for the exam. That's what component 2, the transistor, does. It controls the flow of current. Component 3. So if we were to look at what is component 3, component 3, we may not have necessarily covered it in the class before, but we might have mentioned it. This is a lamp, or you may want to say it's a bulb. It lights up. So it's not an LED, but it's a bulb, or it could be an incandescent lamp. So component 3 in figure T1 is a lamp. So we have labeled it here conveniently for you in blue. Last component on this slide that we need to learn about for the exam is component 4. What is component 4? Well, there's a 4 here, and next to the 4 is this component. And we should all by now recognize this component. What is it? If you were to say it's a battery, you'd be quite correct. So component 4 in figure T1 is a battery. So we have the resistor, we have the transistor. We know the transistor will control the flow of current because it's being used as a switch here. And we know this is a lamp which will light up when the current flows. And we know this is the battery that will power the lamp. So we will now discuss the component that's known as a switch. We talked about a switch before, but let's go a little deeper into what the switch is. This will become very important with some future slides. So let's pay attention. So what's a switch? Well, we are saying a switch is a device that controls the flow of an electric current. And we're saying, think of a switch as a simple on-off control. And if we were to look on the right-hand side here, you will see a little toggle switch. It's either on or it is off. And the most common type of switch is what we will call a single pole, single throw switch. So this here is a single pole, single throw switch. And this symbol is this symbol that you're seeing in the middle of your screen. This is a switch symbol, but it's also the single pole, single throw type, because there are other types. And we have those here. We'll come to them later on. But this is the single pole, single throw switch, which is the generic switch symbol here. But note that we have a couple variations. Single pole, double throw, double pole, single throw, double pole, double throw. But we'll get to a little variation later on. This is the switch symbol. This is what it physically might look like. It's one of the ways it looks. Just now we will come to a slide what switches also look like. And this is the point here. They come in various forms, different sizes. You have toggle switches, push buttons, rotary switches, and electronic switches. So this is a switch. Anytime you see this symbol in a schematic or in a circuit diagram, it's a switch. In this case here, it looks open, so no current flows. When we close the switch and this line connects here, then current will flow. So that is the equivalent of putting the switch on. When the switch is off, then the circuit becomes open like this and no current flows. So that's a switch. Again, for good measure, these are some different types of switches just for your information, extra information that you could look at on your own time. So you have the different types of switches that exist. Right, so before we come back to switches, let's go to another component called a transformer. So we have on your screen some pictures, some diagrams that show what a transformer might be constructed like. So a transformer is a device, it's a component, and what the transformer does, it changes the voltage level from the input side to the output side. So if you were to look at the diagram on the bottom right-hand corner, you will see that we have line current coming in, or voltage of 120 volts coming in. That's your house supply, or that's what you get in your receptacle outlet when you plug in. Many of us, some persons may get a different voltage depending on what country you are located in. But 110, 117, 115, 120 volts AC might be your typical input voltage when you plug into the wall. But the output, the other side of the transformer, this may be a step down transformer. We will get 24 volts out. That's why we call it step down. It can also be a step up transformer, and we can increase the voltage. So essentially, the transformer, that's what it's doing. It's transforming. It's either increasing or decreasing the voltage. So that's what a transformer does. It takes the alternating current and changes it from one value to another. Again, extra information that is useful. It's the construction of a transformer. It's normally two coils. So this is one coil, this is another coil, and you have a core here. And that is what gives the property of a transformer. You have magnetic induction, and it causes a voltage to be induced on the other side, and therefore you have a voltage which could be the same, it could be less, or it could be equal depending on the ratio of the number of turns. So you have a coil here, you may have 16 coil, and this may be 8 coil, so depending on the ratio of the coils, that is what determines whether the voltage is the same, less than, or equal compared to the input. So you have the input of the transformer, you have the output of the transformer, and the ratio of the coils is what determines whether it's a step up to increase the voltage or a step down transformer to reduce the voltage. So just some extra information about what a transformer is. Right, so again, some additional information for you. These things are not in your exams, but of course we always like to give something extra. So this is what physically a transformer might look like if you were to open a power supply or an electronic component or device and you take off the cover. Be careful, very, very careful. There might be live voltages inside there, might be high voltage. But if you were to open up a device like a power supply, you may see something like this, a transformer. So this is what the component called a transformer may look like. And we'll show a picture just now again that shows different types of transformers. We're not going to go through all of these bullet points here. This is just for your own information. You can have a read at your leisure as to what are some of the properties of a transformer. But we will discuss the symbol for a transformer. And on the bottom right-hand corner here, this is the symbol for a transformer. And if you're saying it looks a little bit familiar, you'll be quite correct, because this side looks like an inductor or a coil. The other side also looks like an inductor or a coil. And remember, we said a transformer is constructed that's two coils wound around a core. Well, this is the core representation of the core here, and you have your two coils or your two inductor type arrangements. So the symbol for a transformer is really two inductors back to back with a symbol for the core. So this is your transformer. Should look kind of familiar to you already, because we have dealt with what a coil or a inductor symbol is. But note that this is the transformer symbol. Right, so we did promise you some pictures as to what transformers might also look like. So you have these smaller transformers, the components that may be in electronic devices. And then on the right-hand side, you have the huge, very large transformers. So if you were to walk outside and you have poles with electrical wires running on it, you may see these buckets transformers, or you may see these larger type transformers. You may see some on the ground via substation. Trinidad Tobago TNTech, you will see TNTech substations with large transformers like these. Or if you look up on the pole, you'll see these sort of bucket type looking transformers. And most places around the world, you will have some form of transformer to break down the voltage or step up the voltage. So all are transformers. Again, not for your exam, but just to give you, make it real so we can see what transformers look like. Right. So we talked about what a schematic is. We said that it's important as hams, as amateur radio operators. We may be dealing a lot with schematics. So let's look at a schematic. It's a wiring diagram. Notice the symbols. Now, when you look at this, you may say, whoa, this looks pretty complex. But if you look very carefully, you may find that you know the majority of the symbols here, if not all of them, by now. You say, but wait a minute, we just did transformer. This is a transformer, isn't it? Yes. You have the input side, you have the output side. Then you look at this one, you say, but wait a minute, that looks like a diode. You'd be quite right. Then you'll say, but wait a minute, I'm seeing two arrows coming out of this diode, so it's a light emitting diode. You'll be quite correct. You may say, but wait, I don't quite recognize this one. Well, we'll probably come to that in the future part of the course. It's a Zener diode. We have a resistor, but not a regular resistor. Notice with the arrow coming here, it's a variable resistor, and so on. Look at the switch here. So we should already start, when we look at schematics, things that should start jumping out at us, because we have looked at some of these symbols, we have looked at some of these components, we have started to learn about them. So when we look at this, they should not be any strangers to us. They should be familiar to us. And it's just for us to look at schematics and start to become a little more familiar with the components as they're connected in a circuit or in a schematic. So for the exam, we need to know that, remember we said this is a switch, component 3, it's a switch. But for the exam, we need to know the type of switch represented by component 3, which is component 3. This is component 3. Is a single pole, single throw switch. So that's an exam question, and you need to learn that. So we dealt with what a single pole, single throw switch in a previous slide. Look at this right inside of here on the schematic in a circuit diagram. So pluck it out, pull it out, component 3, isolate it. This is a switch, but what kind of switch it is? Or is it? It's a single pole, single throw switch. Basically an on-off switch. We'll come to some more things about switches later on in the course. We also need to know for the exam, because it's an exam question, component 4. What is component 4? Let's look. Where is it? Component 4. Where are you? Here it is. Component 4. All of this is component 4. Do we know what it is? Yes, we do. We just did it. It's a transformer. So that's an exam question. What is component 4 in figure T2? Which is figure T2? This schematic is labeled as figure T2, and it will be labeled figure T2 in your exam. So don't get tied up when they're talking about figure T2. Just look and you'll see figure T2. Oh, that's the schematic. That's the label, or that's what this particular schematic is being called for the purpose of the exam. Figure T2. What is component 4 in figure T2? There's the 4. It's a transformer. So that will be the correct answer. The next question that you will get has to do with the purpose of a transformer. And that's why we went a little bit into the function, how it works and what it does. So this is an exam question. The component that changes 120 VAC, so don't get too tied up when we're talking about that. That's 120 volts AC as opposed to volts DC. 120 volts DC, AC power to a lower AC voltage is called a transformer. So remember we said a transformer will take an input voltage and transform it or change it to another voltage on the other side. It's almost like the voltage has one pressure coming in and another pressure going out. It could be the same, it could be higher, it could be lower. But in this case here, we have 120 volts coming in, and the device or the component that will change it to a lower voltage. And by the way, this here is a power supply circuit, just FYI. So it will change it to a lower voltage. But what is actually causing that AC voltage to change from a higher voltage to a lower voltage? It's the transformer. So this is an exam question. The component that changes 120 volts AC power to a lower AC voltage is a transformer. Okay, so let's just remind ourselves about the difference between AC and DC. So a similar slide would have been shared a couple classes back. So just remember, this is what an AC voltage looks like. It's varying between positive and negative. It's what you call a sinusoidal wave. So it's going up, coming down, going up, going back through the zero, going up, coming down. So this is alternating current. The voltage varies. Goes positive, goes negative, goes positive, goes negative, pass through zero, goes positive, and so on. But direct current is one voltage level, continuous. So that's the difference. So just bear that in mind between alternating current and direct current as we discuss rectification and power supplies. Okay. So we need to discuss the concept of rectification. So remember we said that we have an AC supply, but we may want to convert it to a DC supply. We may want to not have it be varying, so certain things we need to have a DC or direct current supply. So we need to rectify that AC line voltage. And what do we use? We use a semiconductor component called a diode. Remember we said a diode causes current to flow in one direction only? So that's what, when we pass AC through a diode, what it will do, it will only allow one side, let's say the positive side. So what it does, it chops off the negative side. So if you were to look at what happens here when the AC voltage passes through the diode, it's truncated, it's chopped. You only see the positive, zero, positive, zero. It does not allow the negative through because current flows in one direction through a diode. So, but notice it's still pulsing. It looks AC-ish, right? So it's still pulsing DC or unsmoothed DC, right? So that's called rectification. When we take the AC and want to move it to DC, the first step is rectification. We get rid of the negative side of it and we only have the positive side. We use a diode to achieve that. So in terms of converting AC to DC, because some devices need DC as opposed to AC, you have a power supply that may deliver DC or direct current in the output. So it starts with AC. So when you plug into your wall outlet, you're getting AC or alternating current, as we are aware. But we have to get DC in the end. It has to be nice and smooth and positive and steady. But we have to rectify first. When we rectify using a diode, we will get pulsing DC. So you have different types of rectifiers. So you may get a pulsing with a space and a pulsing without a space. So you have bridge rectifiers. We won't get into that today. But you have different types of rectifiers. But the point is, notice that the AC here is varying between positive and negative. Then all of a sudden, as we rectify it using diodes, we are only seeing the positive cycle now. It's still pulsating, but we want to get it nice and smooth. So we will filter it out, and we'll see in a little while we use a capacitor called a filter capacitor that will start to smoothen it out. And then we'll use a voltage regulator that will keep it nice and steady. So this just shows the process of how we convert AC, alternating current, which you will get in your house supply that you plug your fan or your power supply into on the wall outlet, but you want to get direct current. Maybe you need 13.8 volts DC to power your amateur radio transceiver. And you have to use a power supply. The first stage is to rectify using diodes, and we have some other stages such as a filter that uses a capacitor, and then something called a voltage regulator that we'll cover very shortly. So we're just showing the big picture as to how we convert AC to DC. So let's continue with a couple more slides before we take our break. Right. So rectifiers. So we talked about rectifying the AC and turn it into DC, right? So the component that we need to use after we've reduced the voltage using a transformer is a diode. So again, this is the same power supply circuit that you saw earlier. And the diode, as we discussed, allows the current to flow in only one direction. That's why you'll get the positive pulse, positive pulse, positive pulse. It doesn't allow the current to go back in the other direction, so the negative pulse is dropped off or cut off. So we need to know that when we use an AC current and we change it into a DC current using this method, it's called rectification. So rectification is a process of changing an alternating current into a varying DC current. All right, so we come to now some exam questions in relation to rectification as well as the various components. So notice we again represent on the bottom here, after we use the diode, we get pulsating DC. It's not yet smooth. So we start to smoothen it out using a capacitor. So if you were to look in your circuit here, you will see a capacitor in your circuit. And this component, after it passes through the the diode, it starts to get smoothened by the capacitor. So it starts to filter it a bit more, and it starts to smoothen from this large pulsating DC. I notice it's smoothened quite a bit here. So we need to know that these two bullet points here, these are exam questions, that a rectifier is a device or circuit that changes an alternating current into a varying direct current signal. So this is an exam question that we just discussed the concept about. You need to learn this. Also, we need to identify what component 6 is in this schematic. So let's take a look. Component 6 in figure T2. So again, this is figure T2. What is component 6? We just talked about it. We have it labeled here. It will not be labeled in your exam, but we need to know that this is the symbol for, you guessed it, it's a capacitor. So I'm sure most, if not all of us, are starting to say, but look at that component. I know what that is. It's a capacitor. I'm seeing other components. Look at diode. I know what that is. A transformer. So we're getting quite familiar with the various electronic components that we will encounter as amateur radio operators, as hams. So now is a good time to take a 2-minute break. So we encourage you to get up, take a little stretch, probably have a bathroom break, maybe have a little bit of water, and we will be back in approximately 2 minutes. All right, so just before we recommence, let's just look at some of the comments or questions in the chat. All right, yeah. Good evening, Amsterdam. No problem. Glad you made it. Okay, so Nadia, how do you differentiate whether the transistor is acting as an amplifier or a switch in a schematic? That's an excellent question. So we would have presented a side-by-side comparison of two circuits in the previous class, where you will see the setup where a transistor is used in an amplification application versus a switch application. The difference really is how it is biased, or how you set up the transistor, the voltages that you apply to the various leads or electrodes of the transistor. Remember, you had the emitter, the base, the collector. So depending on the voltages you supply, the components that you connect to it as well will determine whether it acts one way or the other. So I'll encourage you to just look back on that slide. You will see we say I think we labeled it transistor acting as a switch and transistor acting as an amplifier. And you will see a difference in how the circuit is laid out. So it's like a hammer. I mean, a hammer can either drive a nail in or remove it. It's the same hammer. But if I hold it one way, I'm driving the nail in. If I hold it another way, it's pulling the nail out. So it's really what you call biasing the transistor appropriately, and that will determine whether it acts as an amplifier or as a switch. So excellent question there, Nadia. Right. So let's see if we can resume where we left off. Okay. Right. So we left off, I think, at this slide. So again, we have a filter capacitor in the schematic. All right, so let's deal with a couple more components in our schematic that you will get in the exam. These are exam questions. Again, the tip that we give, most of the time when you see something in yellow writing, it's an exam question. Not all the time. Sometimes I highlight other things like when we're doing a formula and so on, we may put it in yellow. But usually for the bullet points, anything in yellow is or are exam questions. So component 8 in figure T2. So let's look at it. This is component 8. But what exactly is component 8? Should look familiar because we dealt with this symbol before. You may say, but it looks like a diode. Yeah, you're quite correct. But I'm seeing some extra arrows coming out of the diode. And you might recall that that indicates that it gives off light. So what type of diode will it be? It will be a light emitting diode. And you'll be quite correct, an LED. So component 8 in figure T2 is a light emitting diode or an LED. Exam question. So just some extra information. Again, this is a power supply circuit. You have the, you plug this into the receptacle outlet. You have a fuse, you have a switch, you switch it on, you have a transformer. Transformer converts from one voltage to another, sends it through the diode or rectification stage, filter it out using the capacitor. And this component here, the LED lights up. And the reason it lights up is because it will tell you that the power supply is on. So oftentimes, you'll find that LEDs are used to visually indicate when the device has power or it's in an on state. Right? So not an exam question per se, but just for you to know the function of the various components. And you might say, well, wait a minute, yes, when I switch on a device, I see a little light comes on. So you're now understanding the components and how it's set up in the circuits to function that way. Another exam question, they will ask you about component 9. So let's take a look at component 9. What is component 9? What jumps out at you here? This jagged zigzag line. You say, but wait, that sounds like, that looks like a resistor. You would be quite correct. But notice it's modified with this arrow. And what did we say when a resistor has this arrow, coming to meet it like this? Well, it's variable, it's not fixed. So that's the answer for this question. Component 9 in figure T2. Remember, figure T2 is the entire schematic diagram. Component 9 on it is a variable resistor. And just again, some extra information for you. The function of this variable resistor in the circuit is to limit the output current. Right? Again, extra information, not an exam question. For those of you who are a little advanced who would like to know, we provide some extra information, food for thought. Okay, so yet another schematic. So we're dealing with quite a few schematics in our time. See how important it is to learn the building blocks of electronics, the various components, and the circuit diagrams, or what we are now calling schematics. It allows us to read these things. And you would be, how much information you already know, quite a bit. So some more exam questions for us. They will ask us about component 3 in figure T3. So what is figure T3? Figure T3 is this entire schematic on your right-hand side of your screen. We have a lot of components in it, and you may recognize most of them or many of them. Well, let's see. Component 3 in figure T3 is what? What is component 3? Let's locate it. This is 3 here. This is the closest component. And we may recognize part of it. We say, but wait a minute, I recognize this. It looks like a coil. Yeah, so that's an inductor. But we have modified the inductor with a symbol added onto it, the little arrow. And you would say, but wait a minute, I remember when we had a resistor and we added this onto the resistor, this little arrow, it made it a variable resistor. Well, guess what? You probably guessed it already. When you add this little arrow in this way onto an inductor, it makes it a variable inductor. So kind of getting with the pattern here, right? So while we might not have discussed the symbol for a variable inductor, we discussed what an inductor symbol looks like. But we knew, or we know, or you know what a variable resistor looks like. So you can extrapolate or conclude, but wait a minute, this is not just any regular inductor. This is a variable inductor. So sometimes you may not have learned a particular component, but you could look at it and probably take a good guess as to what it is, right? If you don't have a reference or you have not yet been told. So what is the component 3 in figure T3? Variable inductor. Let's deal with component 4. What is component 4? Well, component 4 is this triangular looking thing here on the schematic. But what is it? Well, we have labeled it as an antenna, and that's exactly what it is. This is a symbol for an antenna, or one of the symbols that we use for an antenna. So component 4, which is this component here, in figure T3, so this schematic is figure T3. Component 4 is an antenna. Again, both of these are exam questions. All right, so moving right along. Right. So we are coming now to the point where we want to discuss the idea of resonant or tuned circuits. So when we talk about a resonant circuit or tuned circuit, it simply means that that circuit consists of at least two components that we have dealt with already: the inductor and the capacitor. So again, sometimes we'll call an inductor L and a capacitor, we'll call it C. That's the symbol we'll use to indicate that, right? We remind ourselves of the symbol for an inductor, which is here, it's like a coil, and then the capacitor that looks like two plates. But when we combine an inductor and a capacitor in a circuit, and remember we had dealt with the difference between parallel and series circuits. We dealt with that a couple of classes ago. So we can we can connect components either in parallel or in series. So if we have inductor or an inductor, we have an inductor, we have a capacitor, we can connect them in series or we can connect them in parallel. But once we connect an inductor to a capacitor in a circuit, like what we're seeing on the right-hand side here, we have just created a resonant or a tuned circuit by just putting in the inductor and the capacitor. In one of these circuits, we have a little extra symbol here, we have a resistor, but the inductor and the capacitor in circuit like this makes it a tuned or a resonant circuit. And you will need to learn that for the exam. So we say here that a resonant or tuned circuit consists of an inductor and a capacitor, and it can be either in series or in parallel. So on the top here, you will see that we have the capacitor and the inductor going one into the next, daisy chained, and therefore they are in series. Here, you will note that the inductor and the capacitor are in parallel. So series circuit, parallel circuit. So it doesn't matter, both of them are resonant or tuned circuit. We have some extra information here for you that you can read on your own that's shows what's the difference between a series tuned LC circuit versus a parallel tuned LC circuit. But this is extra information not required for exam, but there's a difference in terms of the impedance of the circuit depending on whether it's series or parallel. So extra information here for you. But what you need to learn for the exam are these two first bullet points. So note here, the second one says, a capacitor is combined with an inductor to make a resonance circuit. So that's saying the first bullet point in a truncated way. Again, both of these are exam questions. You have the inductor, you have the capacitor, you put it in a circuit, and you now have a tuned circuit or a resonant circuit. All right, so I did promise that we'll come back to switches. So we talked about the SPDT or single pole single throw switch. Now we come to the SPDT circuit switch. So what's the difference? So the first switch symbol that we have on the left hand side, we dealt with this. We said this is a single pole single throw or an SPST symbol. It's a single pole single throw switch. It's basically an on-off switch or a toggle switch. It's either on when this line meets here, the current flows, or it's off, meaning it's open, so no current can flow. That's the most basic of switches, but it's not the only type of switch. SPST, single pole, single throw, meaning on-off. But we want to discuss another type of switch called the SPDT, which is the single pole double throw switch. So let's blow it up here a little bit. Notice we have this switch leg coming this way, and this can be connected either to this terminal or this terminal. So what that means is that we can switch between the current flowing in this direction or going through in this direction. That's what we mean by single pole double throw. We can throw it either this way or that way. So it's two throws, 1, 2, single pole double throw. And for the exam, we need to know this bullet point here. A SPDT, and SPDT means single pole double throw, switch functions in a way that a single circuit is switched between one of two other circuits. So this one single circuit coming in here, and you have two other circuits here. So you can either be this one or this one. And I'll show a circuit diagram or schematic that will hopefully concretize the use of a single pole double throw switch. Right? So the single pole single throw switch is just an on-off switch. The single pole double throw switch allows you to switch between two pathways. So let's look at what that looks like. Hopefully that will make it a little clearer. But the bullet point here is what you need to know for the exam. Okay, so let's make it real. This is a schematic. It's a circuit diagram. We should recognize most, if not all, of the symbols here. We have the wires that connect the components together. We have our battery. We have our single pole double throw switch. We have a lamp and we have an LED. So that's pretty much it. When the single pole single throw switch is in this position, the current will flow. Conventional current is positive to negative. The current will flow through the lamp or the bulb and come back this way and complete the circuit. That's how the current will flow when the single pole double throw switch is in this position. But what if I throw the switch and it clicks and latches this other part here? So it no longer is connected this way, but it's connected in this way. What means is the current will flow not through the lamp, but it will all of a sudden now go through the light emitting diode or the LED. So what will happen here is that the LED will light up instead of the lamp. And if I switch it back, if I throw the switch back to this part of the circuit, the lamp will now light up. So hopefully that gives us an idea of the function of a single pole double throw switch. It's not just an on-off switch. It is switching between this part of the circuit and this part of the circuit. So either or will be on in this circuit. Either the lamp or the bulb will be on, or the light emitting diode or the LED will be on, depending on the position of this switch. And this switch is an SPDT, or single pole double throw. Right, so let's come to another exciting component. It's called the relay. So what exactly is a relay? So we have our little definition here, and it's an exam question. A relay is an electrically controlled switch. So it is a switch, but let's see what we mean by it's electrically controlled. So first of all, this is what the symbol of a relay looks like. But if we were to dissect it, break it down a little bit, you'll see that you actually know the various pieces of a relay. So the top part, if you were to say this is a switch, you'll be quite correct, a basic switch. As a matter of fact, it's a single pole, single throw switch, right? But it's a switch. And if you were to say the bottom here is a coil or an inductor, you'll be quite correct. And you'll see this here meaning a core. So kind of half of a transformer, right? So you have half of a transformer and a switch. Well, yeah, that's kind of what the relay is, or it's constructed. But we give you a relay on the right-hand side here. And if you can see it, you have the terminals here on the relay. And these terminals at the back here go to a coil. It's an electromagnet. So when you energize this coil with a small current, the coil here becomes magnetized and it pulls these pins in this direction. So that's how the relay works. You energize the coil and it switches between these sets of pins and the other sets of pins, right? So that's why we say that a relay is an electrically controlled switch. You can have a very small current operating this electromagnet, but you can have larger currents being switched using these pins, right? So a relay is an electrically controlled switch. You need to know that for the exam. We're just sharing with you that it uses electromagnetism as the mechanism to operate. When the magnetic field is activated, meaning you apply a current or a voltage to this coil and a current flows, it becomes magnetized and it pulls this latch across here. So the contacts move, it breaks from one set of pins and it makes with another set of pins. And these pins here can carry larger currents. So this is what a relay looks like, or one of the form factors of a relay. And this is the symbol. But what you need to know for the exam is a relay is an electrically controlled switch. All right, some other interesting components that we need to know about meters. So some of us may already be familiar with meters, but we need to know the definition of a meter. A meter is a component that displays an electrical quantity. And we give some examples such as voltage, current, power, etc. as a numeric value. So a meter displays an electrical quantity as a numeric value, and that is an exam question. We put in some extra information here to give it context and for us to understand what we're talking about. On the right-hand side, we show an example of what a meter symbol will look like, and this one is a voltmeter to measure voltage. Right? It's not the only symbol for a meter. It depends on the type of meter, what it's measuring. And we said it can measure voltage, current, power, resistance. Many quantities can be measured via a meter depending on how the meter is constructed and its purpose. So this is an exam question. What is a meter? We have given you here the symbol for the meter, and we have also put up on the screen what a meter might look like. And just extra information, a meter can either be analog, as the one on the right-hand side, where you have a needle or a pointer, and it moves depending on the reading. So this is a voltmeter. So this is analog. And on the left-hand side here, this is a digital type of a display, right? So these are all meters, but this is the point that you need to learn for the exam. A meter is a component that displays an electrical quantity as a numeric value. Good, so a pretty interesting component that we need to deal with, the IC, or the integrated circuit. And we have a definition of what an integrated circuit is, so we need to learn this for the exam. But before we come to the definition, let's look at what an integrated circuit really is and how it looks, or one of the ways it might look. If you were to open a television or a recorder, some electronic device, you might see ICs. If you were to open a computer, you will see ICs. The CPU of a computer or the processor is an IC of sorts, right? So this is an example on the right-hand side what an IC or an integrated circuit may look like. On a schematic or wiring diagram, an IC might look like this. It may have many more pins, but this might be what it could look like. Many representation of what an IC looks like. So we're just giving you one example. And an IC, it's a miniaturized electronic circuit, and it consists of multiple components. So we have dealt with transistors and resistors and capacitors, diodes as individual components on a circuit board. But an integrated circuit can have all of that packed into one little package like this. You wouldn't see it, but it's inside of there. All of those components that's miniaturized. So that is what an IC or an integrated circuit looks like. And you can have either analog or digital integrated circuits. But for the exam, we need to learn this definition at the top here, that an integrated circuit is a device that combines several semiconductors and other components into one package. So this is the definition we will learn. This bit here is an extra information to give you context and also to hopefully aid in an understanding as to what an IC or an integrated circuit is. So let's just show what inside of an IC looks like. We've said it's miniature. Look at all of these tiny components inside of there, and you have the wires going inside. So this is the inside of an IC. So this here is an integrated circuit. If you were to somehow cut this open and use a microscope, this is what you will see. Very, very tiny components. You have transistors and diodes and all sorts of other components inside of there. Miniaturized, shrunk down to a size, and you have literally thousands, or in some cases for CPUs, millions of these miniaturized components. So that's an IC. All right. So another component that we need to learn as an amateur radio operator for our course is a component that's known as a voltage regulator. On the right-hand side, we have an example of what a voltage regulator might look like. But some of you may be saying, but wait a minute, that looking kind of like a transistor, maybe even an FET. Well, yeah, the reality is you cannot always tell what a component is by just simply looking at the package. All right, so you may have to look at the label on the package, the part number, to tell what it is. There are some clues as well. You have a heatsink here. So some people might look at it and say it's a voltage regulator. But it's not necessarily easy to always tell what a component is by just looking at the form factor, right? So this here is a voltage regulator. It's the component, what it will look like on a circuit board, or one of the ways it will look. And here on your screen is the symbol that we will use, or one of the symbols that we will typically use to illustrate or represent a voltage regulator in a circuit or in a schematic. And remember, we had said that when we are in a power supply, we might want to convert from the AC voltage that comes out through our plugs or our receptacle outlets in our wall, and we want to convert it to DC supply for our transceiver, our amateur radio transceiver, 13.8 volts DC. We said that we have to rectify that circuit. We might have to, before that, transform it from 120 volts down to some other voltage using a transformer. After the transformer, we said we need to rectify it because the transformer is giving us AC and we want DC. So we'll use a rectifier using diodes to rectify, but we'll end up with pulsing DC. And then we use a capacitor to smoothen it. Call all of that. We dealt with all of that a little earlier. And then we said we use something called a voltage regulator to finally give it a nice steady state. So let's actually look back at that little diagram that shows how a power supply works. Right, so you have your house supply coming in from the wall outlet, AC line voltage into your power supply. We rectify it, we use a diode and we get pulsating DC. And then we filter it a bit using filter capacitors to smoothen it out. And then eventually we use a voltage regulator to give it nice and steady. So all of these components and others will achieve converting AC into DC. So you see how important these components are to us and understanding what each and every one of those components does for us. So we are the voltage regulator, and we say the voltage regulator helps to maintain a stable and constant voltage in an electrical circuit, regardless of the variation in the input voltage or the changes in load. It keeps us nice and steady, all right? But for your exam, this is the definition that you need to learn. A regulator is a type of circuit that controls the amount of voltage from a power supply. So learn this for your exam. Okay, so let's just make it real again. Let's actually look at, this is not on your exam. You don't need to learn this, but we like to give students, participants, when we talk about components, let's see what an actual circuit diagram looks like, right? Just like Nadia asked a little earlier, how you can tell what a circuit looks like between a transistor that's acting as an amplifier versus a switch. So we're actually showing a full circuit diagram or full schematic of a power supply using a voltage regulator. So here's our trusty voltage regulator. That's what it actually looks like physically. But below here is our schematic diagram. And you were to follow it, you will see that we have the AC supply coming in, you have the transformer to drop the voltage to 9 or 10 volts, you have your rectifier circuit. In this case, it's a bridge rectifier, consists of diodes that will rectify, and you will end up with pulsating DC. Then you have some capacitors here that will do some filtering, and then you have your voltage regulator that will ensure that it is nice and steady and smooth. So you have a nice DC output on the end. So this is what a power supply circuit looks like. So you can build your own power supply. You have a lot of information already to look at a schematic and get components together and build something. Yes, you have quite a lot of knowledge already, folks. All right, so let's just deal with a couple more components before we quickly go through our question pool review and give our this evening's course a wrap. So fuses. So many of us might already be familiar with fuses. So this symbol on your screen here is the symbol for a fuse. And on your right-hand side, we have a couple of pictures as to what fuses might look like. It's not the only representation of what physically a fuse will look like, but these are some of the ones that we will deal with as amateur radio operators, the form factor for fuses. But exactly what is a fuse? A fuse is an electrical component that's used to protect other circuit components from current overloads. So the fuse, if the current exceeds what it should be, will blow. So this fuse here, if you look at the fuse, you'll see a little wire inside of that. That will actually melt if the current that is passing through exceeds. So if this is a 2-amp fuse or 1-amp fuse, and I don't expect more than 1 amp or 1 ampere to flow through my circuit, I put a 1-amp fuse. And if 1 amp flows, or more than 1 amp, I should say, due to a short circuit or some other defect or fault that occurs in my circuit, my fuse will blow. It will melt the wire and disconnect the circuit from further damage or any damage to the other components. So the fuse will sacrifice itself for the other components and blow. So that's the other point that we have here as to what a fuse is used for. It will look differently. So the wire in this fuse, if you could see it on your screen, it's right here. This is the one that will blow or will sever or melt when there's an overcurrent condition. So a fuse protects us. This is your symbol. These are what it looks like. And for your exam, this is what you need to learn. What is a fuse? All right. So last slide before we go to our question pool. So we need to know about the concept of shielded wires. So we probably are aware of what wires look like, So this is an example of some wire, right? You have the actual metal, you have some insulation here, and then you might have some further insulation. But here we have something that's not quite the insulation. It looks metallic, and you'll be quite right. This may be aluminum foil. Right, so you have the PVC or whatever outer jacket, then you will have some insulator here, insulation for the individual wires so they don't touch each other. But then you have this curious bit of foil here, aluminum foil perhaps. That is shielding. So this becomes a shielded wire. And we do that to prevent interference from impacting on our cables or wire, or this wire from interfering with signals on another wire. So that's the concept of shielding. It's wrapping usually something like metal around the wires to keep the interference out, or to keep these wires from interfering with something outside. So at the bottom, this is when you have a shielded wire, what the symbol will look like. It's this dashed or dashed line that will go around whatever is shielded. So it's not necessarily round like this all of the times. It could be oval, it could be different shapes depending on what is shielded. So in this case here, you have one wire that's shielded, but you can have multiple strands of wires or multiple conductors that are all shielded, and it will be a dotted line like this around to represent that the wire is shielded. So again, if you look here, this is your aluminum foil that is throughout the length of this cable here, and it shields the wire from interference coming in, electromagnetic waves that may come in. This aluminum foil will reject it or block it out or stop it from coming in, and it will not absorb into the wire. So as hams, we use shielding as a technique to reduce interference. So all of these things that we are learning have very practical usage. When you become a ham, when you become a radio operator, and you're troubleshooting issues, trying to get rid of interference, you will find that shielding is a technique that you may want to use. But we do have a point that we need to learn for the exam. This is an exam question, which is, it says that a reason to use shielded wire is to prevent coupling of unwanted signals to or from the wire, which is what we just said. We don't want that extraneous signal, electromagnetic interference, those waves coming in and interfering with our wire. So those are unwanted signals. So we shield the wire. That will help reduce that interference. Okay. So let's quickly run through our question pool. And of course, as everyone is perhaps accustomed to by now, what we do is we quickly run through the actual questions that you're likely to get in the exam, what they look like for all of the theory that we have just covered. So we will race through these questions. Let's go. First question in the question pool. What is the name of an electrical wiring diagram that uses standard component symbols? You say, well, what is it? Is it a bill of materials? No, we didn't learn anything about that. Is it a connector pinout? No, we didn't learn anything about that. Is it a flowchart? No. What we learned about is when you have an electrical wiring diagram with standard components, we know that we call that a schematic. Next question in the question pool. Which of the following is accurately represented in electrical schematics? So we did say what we represent accurately are the component connections, how one component is connected to another. All right, next question in the question pool. They're asking us what is component 1 in figure T1. So this is figure T1, component 1. This is component 1 right here. What is it? Well, we know, everyone here knows, don't you? It's a resistor. Let's move on. What is component 2 in figure T1? Let's look at component 2. Aha! Everyone knows what that is. It's a transistor. So that is the answer. Component 2 is a transistor. What is the function of component 2? Well, we dealt with that. We said that it's a transistor, and in this circuit, it functions to control the flow of current. So there we go. That's the answer. Controls the flow of current. It doesn't give off light. It doesn't supply electrical energy. It doesn't convert into radio waves. That's not what that does in that circuit at all. So you see the distractors. All right. So don't get tied up, folks. You have this. All right. What is component 3 in figure T1? Component 3. All right. We said that's a lamp. Okay. So let's see. That is it. It's not a resistor. We know what that looks like. It's not a transistor. We know what that looks like. And it's not a ground symbol. We didn't really deal with that, but it's a lamp. Okay. What is component 4 in figure T1? So you see why we did what we did earlier? It's going to ask us, what are these components? Component 4. What is it? Everyone probably just raised and shouted and said, that's a battery. You'll be quite correct. So folks, you're doing quite well. You know all the answers to all of these questions. High confidence. When you do the practice tests, you should be getting all of these things correctly because you know the information. All right. Next question in the question pool. What type of switch is represented by component 3 in figure T2? Let's look at it. This is figure T2. This is what it looked like in the exam, and they want about component 3. This is component 3. What is that? Well, everyone says, yes, that's a switch, right? And we know it also to be a single pole, single throw. But the question is, what is this item 3, component 3? It's a switch, isn't it? And we know it's a single pole, single throw switch, the most basic of switches, on-off switch. Next question in the question pool. What is component 4 in T2? Let's see. What is component 4? There it is. Component 4. What is it? Yes, it's a transformer, folks. You got that correct as well. That's the answer. This is the answer. Component 4, it's a transformer. Next question in the question pool. What component changes 120 volts AC power to a lower AC voltage for other uses? So again, we're talking about this diagram as well, right? Or we could be talking about this diagram. What is that component that changes the voltage from a higher to a lower AC level? We know that's a transformer. It's not a transistor, it's not a diode, it's not a variable capacitor. So the answer is a transformer. Next question. Which of the following devices or circuit changes an alternating current into a varying direct current signal? So we know that we have the AC and we want to go to DC. We know we have to use a rectifier circuit. And we use diodes to do that, right? So rectifier is the correct answer. Next question in question pool. What is component 6 in figure T2? Let's look back at figure T2. This is figure T2. Component 6. Look for the 6. There's the 6. What component is next to the 6? Everyone is probably shouting, yes, I know this. This is a capacitor. Let's see. Component 6 in T2. You'll be quite correct. It's a capacitor. Let's go again. What is component number 8 in T2? Let's look for component 8. So here is component 8. What's that symbol? It looks diode-ish, right? It looks like a diode, but we have these arrows coming off. So we know that's light, representing light giving off. It's a light emitting diode. So that should be the answer, an LED, component number 8. What is component number 8? Let's see, correct answer, it's a light emitting diode or LED. All right, what is component number 9 in figure T2? Let's look back at figure T2 for component number 9. So in your exam, you'll have this drawing or this schematic or this diagram labeled as T2. And they want to know about component number 9. Component 9 is a resistor, but what kind? It's a variable resistor. Are they asking us about component 9? Let's check it back in the question. Component 9, yes, it's a variable resistor. Look at how they're trying to tie you up, huh? Yeah, so you know it's a variable something, but they're saying variable capacitor, variable inductor, variable transformer, but you know it's not either of those because it's the zigzag line which represents a resistor, so it's a variable resistor. Okay. Let's wrap up with a couple more questions that we have to deal with. What is component 3 in figure T3? So we come to T3 now. So they tell us T3, this is figure T3 in the exam. You have this schematic in front of you. But we are looking for which component? Component number 3. What is component number 3? So let's make sure we see. This is component number 3. And we learned what this is. Yes, it's an inductor, but what type of inductor is it? Notice we have this little arrow that returns here. We know that means variable. So what is the correct answer? It's a variable inductor. Yes, very well done, folks. Next question in the question pool. What is component 4 in figure T3? Again, figure T3, component number 4. Let's identify it. Let's highlight it. There's component number 4. Well, we learned today that that triangular symbol is the symbol for an antenna. So that is the correct answer. It's an antenna. Okay, so a few more questions. Which of the following is a resonant or tuned circuit? So remember when we said and defined what a resonant or tuned circuit, it has to have an inductor and a capacitor, and it could either be in series or parallel. Well, that's the answer. An inductor and a capacitor in series or parallel. That's what a resonant or tuned circuit is. Next question. Which of the following is combined with an inductor to make it a resonant circuit? So we said it's L and C, right? Inductor and capacitor. So resonant circuit or tuned circuit, inductor and capacitor, also known as an LC, right? L for inductor, C for capacitor. Another way to remember, LC circuit. Okay, let's move on. All right, here's a cryptic question. What is the function of an SPDT switch? Well, we dealt with what SPDT meant. We know SP means single pole, and we know DT is double throw, not single throw. All right, so we know that is switching between two circuits, right? Remember we had a little example we showed you there, switching between an incandescent lamp and an LED, right? So that's the SPDT. We are not going to get tied up with this little cryptic SPDT. We know single pole double throw. So it's a single circuit that is switched between one of two other circuits. So that's what the SPDT switch does. Okay, they're asking us, what is a relay? So remember we said we needed to learn the definition. A relay is an electrically controlled switch. Simple as that. It's not a patch transistor. It's not an inverting amplifier. It's not a current controlled amplifier. Right? We learned what a relay is. Electrically controlled switch. Next question in the question pool, folks. Which of the following displays an electrical quantity as a numeric value? We learned that as the definition of a meter. Remember we said we had the analog type and the digital type, whether it's a voltmeter, ammeter, all sorts of meters, but it displays the electrical quantity as a numeric value. It's a meter. Right, next question, question pool. What is the name of a device that combines several semiconductors and other components into one package? When we say when you miniaturize it and stick it into a little package, that's called an IC or integrated circuit. So that's the answer right there. Next question in the question pool. What type of circuit controls the amount of voltage from a power supply? So remember we did the regulator, that's what it's doing. So that's the answer, regulator. All right, next question. What electrical component is used to protect other circuits or other circuit components from current overloads? You remember we said that component that sacrifices itself, it melts, it blows. What is it? It's called the fuse that protects the other circuit component. All right, it's not a tyrotron, it's not a tyrotron, it's not a varactor, So it's a fuse, okay? So last question in the question pool for this evening. Which of the following is a reason to use shielded wire? So we said the reason is to prevent coupling of unwanted signals to or from the wire. In other words, to reduce the interference. That's the purpose of using shielded wire. Okay, so let's come right back to our slide deck. All right. So we have just covered all of the questions in the question pool that you're likely to get in your exam for all of the theory that we did this evening. So we're looking to wrap up now, folks. So on Saturday gone, there was the webinar, and as we had announced. For persons who missed it, if you would like to get the recording, the link is on your screen. It was really fun, folks. We know several persons did make it and attended. We got a lot of feedback, and the panelists were fantastic indeed. We had Khalid Hussain of CNC3 or TT Weather Center. We had Eric Mackey, former weather anchor on TV6 CNC3, now at the ODPM. We had Brian Shields. Many of you may know him as Mr. Weatherman. You all may follow him on YouTube and get those daily updates. And of course, Gary Benjamin, senior meteorologist at the Trinidad and Tobago Meteorological Service. So we encourage you to take a look at it. Weather is important to all of us, and really interesting 1.5 hours or so, folks. So the link is there for you should you choose to check it out. So as always, if you have any questions, Please feel free to send an email. That's my email, robbie@9yankee4r.com. And this is my mobile number. You can WhatsApp me there, any questions, and we'll do our best to answer those questions. So folks, thank you again for the lecture time as well. Next session, God's willing, next Friday at 8:30 p.m. That's Friday the 26th. Thank you so much, everyone. Be safe, take good care, and do have a good night.